What up, calculus students? Here's your Unit 4 review. 36 questions. What a crazy. Yeah, let's get to it. Slope of line tangent, derivative. Let's find y prime. All right, well, it's a quotient, so I have to use the quotient rule. But the derivative of the top is a popular function, e to the negative x. Its derivative is negative e to the negative x. You know, you multiply these together, the negative can come up front. So derivative of the top times the bottom. Well, it's the derivative of the bottom times the top. All over. Bottom squared. Simplify. If you want. I got to just plug in 1, right? So simplify if you have to. Negative e to the negative first times 2 minus e to the negative first over 2 squared 4. What is that? What is that? So many options here. Well, this is negative 2 e to the negative first. This is 1 e to the negative first. I'm subtracting them. I put a 1 there just so I can explain. So I have negative 3 e to the negative first over 4, which is negative 3 over 4e. Pew. Winner. Approximations using a tangent line. Local linearization. Approximations. Very important for these questions. Read what you're asked for. You're asked for the approximation. You're not asked for what the actual value could be. Pay attention. Read carefully. Giving an approximation versus giving you what you think the value is. Two different types of questions related with tangent lines. We'll talk about one of those when we get to it. Here's your point. Here's your slope. So, and I'm going to address both of these. So you got y minus 1 equals m, which is 4, x minus 2. 0.21 slope 4. We're approximating 1.9. So 4 times 1.9 is an x value. And I'm going to add 1 at the end, and that's my approximation for f of 1.9. So this is 4 times negative 0.1 plus 1. Multiplied by negative 0.1 is negative 0.4. Add 1. And 1 plus 0.4 is 0.6. Okay? So this is my approximation. Okay? Now, this is very important, guys. I don't think there's a question like this in the review. They ask you, what could be the value of f of 1.9? It's like use a linear approximation. What could be the value? Not what's the approximation, what could be the value? I'm not going to include 0.6. 0.6 is my approximation. What else do I know? I know the second derivative is 3. So the second derivative is positive. Now let's just assume the second derivative stays positive between 2 and 1.9. Think about this. If your graph has a second derivative that's positive, f is concave up. There's something that's concave up. If you are approximating any point on this concave up function using a line, your approximation on your line is under the actual value. So I would not say the value could be 0.6. I'd say the value could be 0.7 or 1.3 or 1.4. Usually, if they ask you that question, they'll give you like those 3 options. It's like, okay, 0.4, 0.6, or 0.7. Well, 0.6 is an approximation. It's an under approximation. 0.7 would be the value. Okay, so that's a little heads up because you have a question or 2 questions like that where it's talking about the value. All right, approximate is 0. 0 is when y is 0. So I got my point, my slope, y minus 2 equals, this is an f prime, 5x minus 3. A 0 of f is when y is 0. Plug in y is 0. Solve this equation. Add 15. Divide by 5. So that's 2 and 3/5. So 3/5, 6/10, 2.6. I don't like mixed numbers, but it helps for that situation. Number 4 was the absolute maximum value. Value is like a y value. Not y prime, but y, a y value. So what we're going to have to do is first derivative sign analysis to find the x location of the max, and then we're going to have to plug it back into this. Now we've looked at log x over x on our quiz, on our homework. It's just a popular function that's asked of you. You got to use the quotient rule. Derivative of the top times the bottom minus derivative of the bottom times the top, all over the bottom squared. Now, it doesn't say, but it should start at 0 because you got log x in it. So can't plug in a negative value into log, can't plug in 0 into log, so we just get this. Now, what do we do here? We set this equal to 0, we see when it's undefined. You get a 0 in the denominator at 0, well, we're already starting at 0. So I just have to solve the numerator. And we should have done this enough that it's not crazy. Take e to the power of both sides, you get x equals e. Okay, so here's e. Now, that's the x coordinate. Now, let's make sure there's a max. So, remember, take your derivative, plug in e to powers, because e to powers are easy to plug into logs. 1 minus the log of e to the negative second is 1 minus negative 2, which is positive 2. The denominator is always positive because it's a value squared. Well, e to a power is always positive, so the denominator is definitely always positive. 1 minus negative 2, that's a positive. I plugged in e squared. 1 minus log e squared is 1 minus 2, that's a negative. So yes, f is going to go up until x equals e, then goes down. But what is the absolute maximum value? This is an x value. The y value, f of e, is log e over e. The log of e is 1. Maximum value I'm going to get is 1 over e. It's a good question. Number 5. This question. We had this. Critical point. G prime will equal 0 at 2/3. Okay, so we'll take the derivative. Derivative of the first times the second plus the derivative of the second times the first. And when I plug in 2/3, this needs to equal 0. Now it's like seems complicated, but we talked about when you have e and a derivative with e and an x, usually the key to solving is to factor out the e to the whatever power it is. Here, e to the 2/3 k can be factored out. E to 2/3 k always positive, so you almost ignore it. I mean, if this is just like it'll never equal 0, it's never negative, we ignore it. It approaches 0. So what's left? I have 4/3 here, and then I have 4/9 k. And I'm going to solve this equation, which is this set equal to 0. Multiply by 9, divide by 4, k equals negative 3. Negative 3. Yep. Okay. All right, what's this f prime? A is a number. It's a positive number. This is just like a quick little derivative rule, trying to confuse you. Since A is a number, you don't have to worry about using a product rule. If you did the product rule, the derivative of A is 0. So the whole left side of the product rule would go away. You can consider it part of your outside, with your inside being that. Derivative of negative ax is negative a. The derivative of a e to a power, just like the derivative of like 3e to the x. The derivative of 3e to the x is 3e to the x, like the constant you don't have to worry about. So this is a to u a power. So f prime would be the product of these two. Now you multiply a and negative a together, you get that negative a squared e to whatever starts in parentheses, stays in parentheses, like Vegas. negative a squared e to the negative ax. E. All right, this is a quick little derivative rule. It's a product. Use the product rule. Derivative of the first times the second plus the derivative of the second times the first. Do I have to simplify? Well, it appears yes. This is a multiple choice question. When is simplification necessary? When we have multiple choice. E to the x factored out. X could be factored out. X e to the x 2 plus x is the same as x plus 2. Boom. Number 8. I mean, we just did this, so use the quotient rule. Get it right. Derivative of the top times the bottom minus derivative of the bottom times the top all the bottom squared. Okay. Take the derivative. 7 minus 0 plus 1 over x. That's the derivative of log x. Don't forget, log in 1. 7 plus 1 is 8. Hooray. That was an easy question. Maybe it's a quick little reminder. Oh, derivative of log x, 1 over x. We're going to have to do function analysis of log x. Oh, you remember the derivative of 2 to the x? How can you remember that? I don't know. How do you remember the derivative of e to the x? You remember it's just e to the x. Like the derivative of e to the x is the derivative of e to the x, is e to the x. It's itself. But you could put a natural log e here. It's just we don't because the natural log of e is just 1. So this is why we remove it here. But maybe that's how you remember, oh, I need this natural log of the constant after. It's something you have to know. 11. Ooh. What's the natural log of f prime of 2? Well, let's just work our way from inside out. Don't freak out. It's not like they're not asking. I thought this is going to be what's the derivative of the natural log of f prime of 2? And I'll do that for you in a second. But this is just what's the natural log of f prime of 2. Well, what's f prime of x? Well, it's just e to the x. It's derivative of the x. What's what f prime of 2? E squared, right? So this turns into the natural log of e squared, which we know is 2. Now, what if the question was, what's the derivative of the natural log of f prime of 2? Maybe instead of f prime of 2, it'd be like f prime of x at x equals 2. Okay? You'd have to use a chain rule. Log x is the outside, f prime is the inside. This is interesting. We'd have 1 over the derivative of the log, and derivative of f prime is f double prime. So you'd have 1 over f prime times f double prime, and then plug in 2. F double prime is the same as f prime, which is just e to the x, e to the x. So it'd be e squared over e squared, which is 1. Where did this come from? I just made it up, okay? This is not part of the problem. It's just like if you had this, remember the chain rule. It's not it. Here, you just need to find f prime of 2, plug it into the log, and know that log e to a power is a power. What is x squared minus 3? E to the negative x increasing. Okay, function analysis. F prime. You take the derivative. Product. And when I take the derivative of e to the negative x, which we already did, negative e to the negative x, just don't forget that. It's a chain rule. Derivative of the first times the second, plus the derivative of the second, negative e to the negative x. O is e to the power, I is negative x. So derivative of the second times the first. Typically factor out e to the power. But I'm going to factor out, just kind of thinking ahead, a negative. Yeah, I'm going to factor out a negative. Pay attention to this, though. That's important. Why am I factoring out a negative? Well, that makes this 2x a negative after I factor out a negative. But it makes this a positive x squared minus 3, which I want. to solve this equation equal to 0, positive x squared for factoring purposes. So negative e to the negative x, this is x squared minus 2x minus 3, which is x minus 3x plus 1, giving me negative 1 and positive 3 as my zeros of f prime. Now, careful. E to the negative x, this is always positive, right? But that negative makes that outside negative. So it's a positive times the negative coefficient is important. So I plug in something like 4, positive, positive, negative. And then the signs will change. And you can check this. Plug in something like 0. Negative, positive, this would be a negative. It would be negative 1. All right, so when is this increasing when is f increasing? When f prime is positive. Something is increasing when its derivative is positive. Negative 1, 2, 3. D. My friends, the inverse derivatives. F's got AB. If its slope at the x-coordinate A is C, G's got to have the point BA. That's what it means to be an inverse. It takes what you have and goes backwards, undoes it. Means G prime B has to equal the flip of the slope, dB over dA. This would turn into dA over dB. That would be the slope. dA over dB is 1 over dB over dA. That's confusing. Just keep it with this. G prime of 3. 3. Well, I need the slope of f when its y-coordinate is 3. Slope of f when its y-coordinate is 3. You might be thinking, oh, 315? Nope. I want this point, 6, 3. And that means I want to know the derivative of f at 6, which is negative 2, which means the derivative of g at 3, the corresponding point 36, would be negative half. Too many people just like go to f prime of 3, negative 8, they answer negative 1/8, but they're not thinking about the table, like flip-flop points, flip-flop slopes, reciprocal slopes. All right, same deal. H inverse prime of 2. Well, H inverse has some 0.2 comma something. H has some point something comma 2. I need H prime at that x coordinate, and then I'll know H inverse prime at 2. Well, we're told H of 1 is 2. So I need to find H prime of 1. This is H. This is H prime, 5x to the 4th plus 3. H prime of 1 is 8. That means H inverse prime at 2 is 1/8. Same deal. G prime of 1, what is it? I don't know. It's at the point 1 something on G. I don't have G, but I do have F. And I am told, like I told you, like for your quizzes, like on your tests, it's going to be the same thing. 0, 1 is on the graph of F. So when the y coordinate is 1, the x coordinate is 0, I need to find f prime of 0. So f prime is 2 plus e to the x. F prime of 0 is 2 plus e to the 0, which is 3. Which means g prime of 1 has to be 1/3. Flip-flop points, reciprocal slopes. That's inverses. Getting tired of these. I did a whole homework video earlier on these. Oh, hooking you up. G of 2 is 1. Maybe it's a hookup. Maybe this is confusing you. G of 2 is 1. What's G prime of 2? Well, since you're given information about f, you need to know that we need to figure out the slope of f not at 2, but at 1. Flip-flop points. You need f prime of 1, not f prime of 2. But they did give you that point on G rather than the point on f, which you're used to. F prime, 3x squared plus 1. F prime of 1 is 4. G prime of 2 has to be 1/4. Arctangent's derivative. Well, this is known. I think he had the exact same question on the homework. Maybe there's a reason for it. Who knows? Arctangent's derivative is 1 over 1 plus x squared. Arctangent parentheses derivative is 1 over 1 plus parentheses squared. Derivative 4x4, y prime, 1 over 1 plus 4x quantity squared times 4. At 1/4, 1 over 1 plus 4 times 1/4 squared times 4. This is 1. This is 4. This is 2. 4 over 2 is 2. There's another way to get that answer that I'm not going to show you. Arcsine's derivative is 1 over root 1 minus x squared. Arcsine parentheses derivative is 1 over root 1 minus parentheses squared. You just got to know them. I'll be able to show you how do you get those next unit. It'll confuse you right now. Why? Might not, actually. But anyways. Oh, I just want the derivative. So 1 over root 1 minus 5x squared times 5. That's 5 over root 1 minus, make sure you square 5x, not just x. 25x squared. Okay, E. We are more than halfway there. All right. Good to have one of everything. The derivative of arc cosine is just like arc sine, only it's the opposite. It's negative. So the derivative of arc cosine is negative 1 over root 1 minus parentheses squared. So got negative 1 over root 1 minus what starts in the parentheses stays in the parentheses times 2x. This turns into x to the 4th. The 2x can go up top, so I have negative 2x over root 1 minus x to the 4th. Negative 2x. Whoa. There. Negative 2x over root 1 minus x to the 4th. Okay, the derivative of arctangent, that's that. The derivative of 2 root x, I write as 2x to the 1/2. Move that down, subtract 1. X to the negative 1/2. So that gives me 1 over 1 plus x squared plus 1 over x to the 1/2. I feel like they want me to simplify that, but apparently not. So that's it. All right, inverse trigs. There's a lot of inverse trigs on this. The derivative is that for arc sine. Plug in root 3 over 2. You get 1 over root 1 minus 3/4. We need to be able to do this. This is 1 over root 1/4. Root 1/4 is 1/2, giving me 1 over 1/2, which is 1 times 2. Boom! All right, I'm tired of these inverse Trig. Can we do some function analysis or some others? All right, maybe more inverses. What is f inverse prime of 2? All right, well, f inverse has got 2 something. F. To find inverse prime of 2, you need the derivative of f when its y-coordinate is 2. Its y-coordinate is 2 when its x-coordinate is 1. F prime of 1, I'm told, is -8. So that means f inverse prime at 2 is -1/8. Which the following is true. Maxes, mins, increasing, decreasing, discontinuous. It looks like I need to take a derivative. Oh, I for this. I shouldn't have to show you, but I'm going to. -2e to the -2x. When does this equal 0? Ah, it's not that. It's not that. It says at x equals 0. This is important. Sometimes you don't have to do a full sign analysis. Now when I don't have to, you had a quiz question like this. What is f prime of 0? 0 plus -2e to the 0, which is -2. F prime of 0 is -2. F is decreasing by 2 y's per x at x equals 0. F is decreasing, right? If the derivative is negative, the original function is decreasing. Next. Oh man, log x over x. Again, man, if you don't have a log x over x problem, that'd be crazy because we have so many. To the top times the bottom minus the derivative of the bottom times the top. All the bottom squared. This is I feel like we've already done this problem. Yeah, I feel like I'm redoing a problem. F prime signs, F is going up, going down. Go back in the video to see that analysis. Didn't ask you about concave up or concave down, so that's nice. But maybe it would. 25. Come on. Okay. Minimum value. Value. So y value. I think we need some more tangent approximations. We don't have any tangent approximations. This is good. Derivative of the first times the second plus the derivative of the second times the first. That's log x plus 1. When does that equal 0? We're going to do a function analysis. Minimums. Okay? Function analysis. Subtract 1, log x equals -1. E to the power of both sides. I get e to the negative first. I'm going to start at 0. It should be told to you. In this case, it isn't. Yeah, e to the negative first. Assuming that's going to be a location of a min, but let's double check. E to the negative second is a good test point. E squared, e cubed, good test points. So f prime of e to the negative second, log e to the negative second plus 1. That's -2 plus 1. That's a negative. F prime e cubed, log e cubed plus 1, 3 plus 1. Means f's got a minimum at 1 over e. But it's not the answer. What is the y value there? I don't know why there's two questions that kind of test you on that. So I need to find e to the negative first. plugged into the original equation. Negative e to the negative first, negative 1 over e. Very probably the same as what you would have selected if you didn't read carefully and said, not what is the location, x-coordinate location, but what is the value. 26. Hey, look at that. Concavity. Remember what you got to do for concavity? You got to figure out when f prime's going down. To figure that out, you need to find when f double prime's negative. That's what f is concave down. Got to use the product rule. Derivative of the first times the second plus the derivative of the second times the first. Factor, then take the derivative, or just take the derivative right away. If you took the derivative right away, this is what you get. The derivative of this piece. You don't need the product rule because it's just a constant. Plus the derivative of this. How are you going to take the derivative of this? Product rule. Derivative of the first times the second, plus the derivative of the second times the first. A lot of e's. Factor it out. 2 plus 2x plus 2. When does that equal 0? It's when 2x equals negative 4. X equals negative 2. Second derivative, negative 2. E to the x is positive. Don't worry about it. If I went to the right of negative 2, positives here. If I went to the left, negatives. So that means f prime is going down and going up. Sign of a derivative tells me if the original thing is going up or going down. That tells me if f is concave down or concave up. F concave down when x is less than negative 2. Let's keep going. 27. Inverse. Great. Oh, I know there's a couple. Not that many linear approximation questions here so far. I wish there were more. So hopefully you redo the quiz. We'll see. Hopefully there's more. Inverse of f. All right, I don't know. What do we know about the inverse of f? Well, we do have f as a point 10, 5. And we know f prime of 10 is 8. All right, so I know f inverse as 5, 10. I know f inverse prime at 5 is 1/8. That's what I know. F inverse prime at 5 is 1/8. That's it, guys. That's it. You got to know that. What it means to be an inverse, you undo. Flip-flop points. What it means to be inverse means slopes are flip-flopped. dy over dx turns into dx over dy, which is 1 over dy dx. F and G are inverses. F's got negative 5, 7. G prime of 7 is 3. Which of the following statements must be false? Let's see. There's a question that Huffaker and I have looked at before and blew our minds how we got it wrong. I don't think we'll see that. Filling out my table, this is what I get. F prime of negative 5 has got to be a third. That's got to be true. Yeah, I think this is the question. So this is true. Which one of these is false? It's I don't know. And here's the thing. This question's not important. But it comes down to the fact that functions and their inverses, so that they're both functions, have to kind of be 1 to 1, which means they can't be going up and down a lot. And since f prime's positive at -5, this function must be increasing everywhere, which means the derivative has to be positive everywhere, which is why this has to be false. This is a very tricky question. Don't stress about this question, not knowing that at all. Here, what's important? This. Let's pretend you didn't even know this question. But the answer is A, one only. That's the false one. Don't worry about it. Did you know this? Did you get that? Did you get that table? Then you're fine. You'll be fine for your test. Trust me. I made your test. I know what's on it. Okay. This is interesting. I don't know where to go here. So like I've never done this problem before. So like, what do I got? I got this. So f inverse when the x coordinate's 10. I need some f function whose y coordinate is 10, whose derivative at the x coordinate is -8. Okay? Okay. Y coordinate is 10, x is 1. Right? So f prime -5, it doesn't equal -8 at 1. So that one's out. Y coordinate's 10. 1, I think, works. 1, like -2 minus 2 plus 14, 10. So x equals 1 again. The derivative at 1, it looks like we're going to have 1 everywhere. The derivative at 1, we want to equal -8. F prime equals -6 x squared minus 2. Aha! F prime at 1 is -8. B looks correct. Let's just double check. Let's look at C and D. If I plug in 1, I get 10. So like -1 minus 4. So let's find the derivative of 1. The derivative is -5x to the fourth minus 4. If I plug in 1, I get -9. That's not what I'm looking for. I'm looking for this derivative that equals -8. How do I get 10 here? I don't know how to get 10 here. It's not 0. Yeah, it is 0. It is 0. Because f of 0 is e to the 0 minus 0 plus 9, which is 10. Okay, so this has the point 0, 10. Let's find f prime of 0. F prime is -2 e to the -2x minus 1. F prime of 0 is -3. That's not -8. So B is the right answer. B is the only function where the derivative, when its y coordinate is 10, is -8, giving us this f inverse prime at 10. That was fun. Got any linear approximations? Oh. What does f have a relative max? Let's do a nice little function analysis. Derivative of the first times the second plus derivative of the second. OI e to the power -x squared, -2x e to the power. E to the -x squared times -2x is the derivative of the second. Don't forget to multiply by the first. We need to set this equal to 0. Fortunately, we're not finding the y value, just the x value. So let's factor out the e to the -x squared, which is always positive. And then I have 2x plus -2x cubed, -2x times x squared. Probably should factor out another x, or maybe I'll put that x here. I'm going to factor out 2x, because then it'll be 1 minus x squared. That gives me three solutions, negative 1, 0, and 1. I could factor this to be 1 minus x, 1 plus x if I wanted to. Now, when do we have a relative max? Okay, well, let's check our signs. I'm literally just going to ignore this. It's positive. So I have 2x times 1 minus x squared. If I plugged in 2, positive, this will be a negative. If I plug in a half, positive, 1 minus a half squared is going to be less than 1, so that's a positive. So I got a positive. Negative a half is negative, positive. And then negative 2 is negative. This would be a negative. So F is going up, down, but max is at negative 1 and 1. Good question. Good little function analysis of the EDX question. That is next. Whoa! Woo! Okay, let's see. The table above gives selected values for a differentiable and increasing function f and its derivative. Let g be the increasing function given by g of x equals that, or g of 3 equals f of 3 plus f of 6, which is 9. Which of the following describes a correct process for finding g inverse prime of 9? I'm just going to start with my table, okay? I got g9 comma something, g inverse, 9 comma something, okay? Now, that's g inverse. G something comma 9, okay? G of 3, I was just told, is 9, right? G of 3 is f of 3 plus f of 6, which is 9. So G of 3 is 9. So if I find G prime of 3, I'll take the reciprocal of that and get G inverse prime of 9. What's G prime? F prime, I'm taking the derivative of this, plus, it's a chain, OI, f of 2x, f prime 2. F prime plus f prime of 2x times 2. So this is f prime of x. And then I'm going to plug in 3 into that. F prime of 3 plus f prime of 6 times 2. Okay, so I want 1 over g prime of 3. Don't worry about all this extra stuff. This is like coming from the formula. F prime of, they aren't even giving us values, but g prime of 3 should be in the bottom. So it's a or b. I need 1 over g prime of 3. So like g inverse prime of 9 is 1 over g prime of 3. G prime of 3 is f prime of 3 plus 2 f prime of 6. That's tricky. It's a good question, though. They don't even use the values. They could have used the, we could have used the values if we wanted to. Good challenger question. You don't need the product rule when it's just a constant. Just leave it. This is a pretty simple problem here. Cosine of 0 is 1. That's 0, not 6. 8 plus 3, 11. Approximations. Look at that. Good one. Approximations and over or under estimates. Okay. I got a point and a slope told the concavity of f. Approximating that. All right, ready? Y minus 7 equals 1/5 x minus 4. F of 3.5 is going to be approximately 1/5, 3.5 minus 4 plus 7. That's 1/5 times negative a half plus 7. That's negative a tenth plus 7. It's negative 0.1, so that's 6.9. Okay? F of 3.5 is going to be approximately 6.9. Over or under. F is concave up. Graph something concave up. Graph a tangent line anywhere. You are using a line to get a value 6.9. I don't care where it is. What is this value? Under the actual value on the graph of F, which is concave up. So, under approximation. Okay. So we have a couple more approximations. Great. Same question. Point, slope, concave down, approximate G of 2.6. Y minus 2 equals negative 3/4 x minus 3. G of 2.6 is approximately negative 3/4, 2.6 minus 3 plus 2. Add the 2 over to the right side. This is negative 3/4 times. This is negative 0.4. Now, not sure what to do here. It's 4/10, negative 4/10, or negative 2/5, which gives us 6/20. Soft. Negative 3/10, positive 3/10, 3/10 plus 2, 2.3. 2.3, 2.3. G is concave down. This is something that's concave down. Draw a tangent line anywhere and realize my approximation is over my actual. Overestimate. Okay? Make sure you're paying attention to what is asked you. Is the approximation asked of you? Or did they ask you to find what could be the value? Okay? If the question was what could be the value, I wouldn't circle 2.3. 2.3 is an approximation. I know it's an over approximation. I would circle something less than that. I don't know if you have any questions like that. You did on your quiz. Oh, yeah, let's do this. Points of inflection. Going off of this guy. Woo! All right, ready? It's already y. Make sure you pay attention to what you have. I'm starting with y, so I have to take the derivative twice. All right, remember the derivative of e to the negative x is negative e to the negative x. So negative e to the negative x plus, let's do the product rule for this guy and the product rule for this guy. It's a great question. It's an annoying question. Derivative of 2x, derivative of the first times the second, plus the derivative of the second times the first, plus the derivative of the first times the second, plus the derivative of the second times the first. I have to simplify this. I have to. This is so messy. Factor out an e to a negative x, and you get negative 1 plus 2 plus negative 2x plus 2x. Keep neat and orderly, especially when things are long, which I didn't do. You get negative 1 plus 2 plus negative 2x plus 2x plus negative x squared. Okay, fortunately, my first derivative does simplify to be 1 minus x squared. Okay, those two x's are gone. That's nice. All right, now let's take the derivative again. Y double prime. Derivative of the first times the second plus the derivative of the second times the first. That equals 0. Factor out e to a power. I'm going to start by factoring out the positive. You got to be careful though. Factor out the negative. Why? So that you don't forget to take that negative and distribute it in. All these little details are important, guys. If you're not paying attention to the details, you make mistakes. I factor out the negative e to the negative x, leaving me with 2x. Let's come up here. Um, I don't like the negative x squared, so I actually should have factored out the positive. Making this x squared positive, this 2x negative, this 1 negative. Um, I can't factor this. I'm worried about using the quadratic formula or completing the square. I'd add 2 to both sides. Yeah. Listen, all the equations you have on your test are factorable. This one you have to use the quadratic formula or complete the square. You guys remember that? Let's remember the quadratic formula. I'll show you both. X equals negative b. It's not negative b, it's the opposite. X equals the opposite of b plus or minus the square root. This is how I taught my Algebra 1 students. They had to sing it. Of b squared. Just do the squaring of b because you're smart enough. Minus 4ac. 4 times a times c is negative 4. All over 2a. 2 plus or minus root 8 over 2. This is 2 plus or minus. This is root 4 root 2, which is 2 root 2's. This is 2 plus, divide everything by 2. 1 plus or minus root 2. Ha! Or, let's complete this square. How do you complete this? And I know it's going to be both of those because your signs are going to change. I'm not going to do any sign change. And also, those are the only possible answers. I'm not going to do the sign analysis. Or, you guys know how to complete the square? Um, what is a perfect square with x squared and minus 2x? Well, I want a negative 1, I want an x minus 1 squared. X minus 1 squared. X minus 1 squared is x squared minus 2x plus 1. So I don't have a plus 1, I have a minus 1. So I need a plus 1, so I'm going to add 2. Okay? So that gives me, x squared minus 2x plus 1 equals 2. Well, that turns into x minus 1 squared. Well, now, since I have a perfect square, I can square root both sides, giving me x minus 1 equals plus or minus root 2. Add 1, x equals 1 plus or minus root 2. Yeah, I'm sorry about this question. Guess what? Everything on your test you can factor. Okay, so I'll tell you that. This is a good little review. Last question. When is f increasing? Great. From negative pi over 2 to pi over 2. Okay. Something's increasing when the derivative is positive. We have to do a sign analysis of the derivative. Quotient, product rule. Derivative of the first times the second plus derivative of the second times the first. When does that equal 0? Factor out the e to the negative x. What do I got? Cos x minus sin x. E to the negative x, always positive. Cos minus sin x. When does that equal 0? This is the deal where tangent equals 1. How do you get there? Subtract cos x, divide by negative 1. It's pi over 4 and 3 pi over 4. So pi over 4 is the only value between negative pi over 2 and positive pi over 2, right? That's when sine and cosine are the same, which means you subtract them and then 0. So what do I plug in? I can plug in 0, and I can plug in, I don't know, like pi over 3 is between pi over 4 and pi over 2, or just assume the signs change. That's probably safe. If I plug in 0, e to the 0, that's positive. We know this is positive. Cosine of 0 is 1, sine of 0 is 0, so this is positive here. Plug in pi over 3, and I honestly could plug in pi over 2 because I know the next solution isn't going to be until 5 pi over 4. Pi over 4 and 5 pi over 4. I hope I said that earlier. So if you plug in pi over 2, this is positive. 0, that's positive 1, but that makes it a negative. So that just confirms things. You don't have to do anything really crazy. When is f increasing from negative? That's a negative. Pi over 2 to pi over 4. There you go. Okay. And that's it. That's the review video. Let's talk about this, guys. What didn't we see a lot of? I thought we did a good job with log x and e to the x and some function analysis for that. I thought we did a good job on inverse derivatives. What we didn't do a good job was a couple things. E to the x and log x, derivative rules like table problems. So the last couple questions on your quizzes, 41 and 42, those table problems, make sure you do those. Another thing, from the log lesson 42, the piecewise functions. Remember we reviewed like unit 2 piecewise functions and when piecewise functions are continuous and when piecewise functions are differentiable. Review that. What else did we do? Wasn't a lot of tangent line approximations. Approximating the square root of a number close to 9 or something like. What's the approximation of the square root of 9.2? Using a tangent line at the 0.93 on the graph of the square root of x. You'll see one of those over-under approximations. Make sure you talk about, and then like that one multiple choice question on your quiz where it's like approximate the actual value. Understanding that. Okay. So that is that. Let me know if you have any questions. I am back in school on Monday, so can answer questions then later.